All right, so you're ready to build your first search engine. I'm talking about a real, powerful search engine that goes way beyond those basic database queries. If you're a junior developer looking to add a seriously valuable skill to your resume, you are in exactly the right place. Let's kick things off with a problem I bet you've run into before. Does this look familiar? Yeah, we've all been there. You build an awesome app, but the search feature, well, it feels kind of slow, a little clunky. That simple like query that was lightning fast when you had 100 records is now just crawling now that you have thousands. This is a classic growing pain, and it's the sign that you're ready to graduate to a real search tool. So what's really the difference here? Well, think of your relational database like a super organized spreadsheet. It's perfect for structured data, for exact lookups. But a search engine, something like Elasticsearch, is built for the messy, unpredictable world of human language. It's designed from the ground up for two things: incredible speed and, most importantly, relevance. It's all about finding that needle in a giant haystack of text. Here's our game plan for today. We're going to tackle this in 5 clear stages. We'll start by laying the foundation, then we'll get our hands dirty indexing some data, build a real project you can show off, learn how to keep it running smoothly, and finally get you ready for that next job interview. Okay, first things first, let's get our environment set up and, translate some of this core jargon into plain English so it all actually makes sense. Forget about complicated installations. Seriously, as a developer, Docker is your absolute best friend. With just 2 commands in your terminal, one to pull the official image and one to run it, you can have a single node Elasticsearch cluster up and running on your machine in literally minutes. This is, without a doubt, the fastest way to start playing around. To make sense of the terminology, let's use a super simple analogy. Think of an index as the entire filing cabinet where you're going to store related information. A document is just a single folder inside that cabinet. And of course, every folder needs a label, right? Well, that's your unique ID. See? It's really that straightforward. All right, with the basics down, it's time to actually put some data into our new filing cabinet. In this section, we're going to cover how to make that information searchable and understand the little bit of magic that makes it all so fast. This right here, this is the secret sauce, an inverted index. Instead of scanning every single document for a word, which would be incredibly slow, Elasticsearch does something much smarter. Imagine the index at the back of a cookbook. You look up the word chicken, and it tells you exactly which pages, or in our case, which documents, contain that word. That's why it's so unbelievably fast. These 4 actions are going to be your bread and butter. You'll be using these simple API calls every single day. First, you create an index. That's like setting up a new empty filing cabinet. Then you start indexing documents, putting folders into it. From there, you can easily grab a specific document using its ID, or, of course, perform a search across everything. Now, this is a really crucial point, one that trips up a lot of beginners. You have to understand the difference between text and keyword. Use the text type for stuff you want to do a full-text search on, like blog post content or product descriptions, but use keyword for things that need to be an exact match, like tags, status codes, or email addresses. Getting this right from the start will save you so many headaches down the road. Ever wonder how Elasticsearch actually sees your sentences? The Analyze API is basically your microscope. You can give it a phrase like the quick brown fox and see exactly how it gets broken down into smaller searchable pieces or tokens, like quick, brown, and fox. It's an absolutely amazing tool for debugging why a certain search isn't behaving the way you expect. Okay, that's enough theory. The absolute best way to learn is by building something. So let's take these concepts and apply them to some real projects you can actually put in your portfolio. A fantastic first project is building a search for an e-commerce catalog. It's the perfect real-world scenario because it forces you to think about practical things, like how do you filter by brand or sort by price, and of course, search through all those product descriptions. A project like this looks amazing on your portfolio. And now we level up. Search is great, but what if you want to actually understand your data? That's where aggregations come in. They let you ask bigger questions like, how many products do I have in each category? Or what are my top-selling brands? This is really the foundation of analytics and building cool dashboards. And this is what that looks like in the real world. With just a single aggregation query, you can turn thousands of individual blog posts into a simple, insightful chart, just like the one you see here. This is the core building block for any kind of dynamic filtering UI or powerful analytics dashboard. So you've built your project, it's looking good, and now it's time for the real world. Let's talk about the professional habits you need to develop to keep your search engine healthy and, more importantly, your data safe. This command right here is about to become your new best friend. The CAT APIs give you a simple, human-readable snapshot of what's happening inside your cluster. Running this little command gives you a quick pulse check on your nodes, your CPU, your memory usage. It's the very first thing you'll run when you're troubleshooting. I know, split brain sounds absolutely terrifying, but it's really just a classic networking problem where your nodes get confused and can't talk to each other. Knowing how to methodically fix it is what separates a junior dev from a seasoned pro. And this isn't just about server uptime. It's the kind of skill that saves you from a 3 a.m. panic call and really gets you noticed by your team. Being a pro is all about discipline. Use ILM, that's Index Lifecycle Management, to automatically manage your data over time, like moving older logs to cheaper storage without you lifting a finger. Take regular snapshots so you can always recover from a disaster. And please secure your cluster with authentication and API keys. Don't leave the front door wide open. You have come a long way. Let's wrap this all up by focusing on how you can turn this powerful new knowledge into a real advantage for your career. Okay, this is a classic interview question, so let's make sure you nail it. The interviewer wants to know if you really understand how a cluster is organized and works together. They're going to ask, so what's the difference between a master, a data, and a coordinating node? And here's your cheat sheet. The master node is the manager. It keeps track of the whole cluster's state. The data nodes are the workhorses. They're the ones actually storing and searching the data. And the coordinating nodes are like receptionists. They just direct traffic and gather up the results. Understanding this separation of jobs is absolutely key. So where is all of this headed? Well, the future is all about understanding meaning, not just matching keywords. New technologies like semantic and vector search, which are powered by AI, let you search by an idea or a concept. This is the real cutting edge, and it's an incredibly exciting area to keep your eye on as you grow your skills. So think about it. You've gone from a slow, like query, all the way to understanding the architecture of a powerful, distributed search engine. You now have the ability to take massive amounts of information and make it instantly accessible and understandable. The only question left is, what are you going to help the world discover next?